Hey guys, and welcome back. My name is Miss Danielson, and today we're having a look at factor spiders and prime factor trees. If at any point during this lesson you feel like you need a little bit more of an introduction to prime numbers, check out the introductory lesson to factors and prime numbers, which I'm linking down in the description box below. Otherwise, let's get started. First of all, let's start with some definitions, and you're going to want to write these down. Factors are whole numbers which evenly divide a value without producing a decimal answer. For example, the factors of 6 are 1, 2, 3, and 6, because we can divide 6 by any of these values and we get a whole number answer. Factor pairs are the result of dividing some value by its factor pair. So for example, 6 divided by 2 equals 3. 2 and 3 are factor pairs of 6. Prime numbers are whole numbers which have precisely two factors. That's just 1 and that number itself. Because of course all values could be divided by 1, and when you divide any value by 1, your answer stays the same. So now that we've got the basics down, let's get into how do we find factors. We're going to use these factor spiders here. I hope nobody's afraid of spiders. It's just a visual way of recognizing our factors in order and knowing when we can stop once we've found them all. So let's set up a factor spider for the factors of 18. First, we need to consider all of the possibilities, all of the possible values we might try dividing 18 by. We could try any number between 1 and 18, because of course, if you divide 18 by some number bigger than 18, you're going to get a decimal answer. So these are my possible factors. That's not to say that they are all factors. We're going to try and find out. First, we'll start by looking at the lowest factor. And by dividing by that lowest factor, we find the highest factor pair. Now, as we said before, all values can divide by 1, so that's my lowest factor. And when I divide 18 by 1, the answer is 18, so that's my highest factor. That pair of factors belong together, like a pair of shoes. Notice how my spider has got a pair of red shoes, a pair of orange shoes, a pair of yellow shoes, and a pair of green shoes. Now, I don't want to mix those up. I want to keep them in order. So I'm going to put this pair of shoes on my factor spider. Here's my factor spider. 18 is the number I'm looking for the factors of, and I'm going to put a pair of shoes where the lowest factor is 1 and the highest factor is 18. See how that's nice and balanced on the left and right hand side? Let's keep going now. Find the next smallest factor, and its factor pair will be the next biggest factor. So looking at the possible factors, I'm looking at the next smallest number to try is 2, and I do see that 18 can divide by 2. 18 divided by 2 would be 9. If 9 is the next biggest factor, we skipped over 10, 11, 12, 13, 14, 15, 16, 17. None of them could possibly be factors of 18, because if they were, they would have a smaller factor pair somewhere between 1 and 2, and that would be a decimal value. So we're eliminating the possible factors quite quickly this way. Let's keep going. If we keep working from lowest to highest and highest to lowest, we will eventually meet in the middle. So now the only possible factors we could try are between 3 and 8. Our next smallest possible factor is 3, and 18 does divide by 3. 18 divided by 3 is 6. I've now eliminated the possible factors 7 and 8 because they're higher than 6, and I don't have a factor pair for them that's lower than 3. So the only two possible factors I have left to try are 4 and 5. Can I divide 18 by 4? No, not without getting a decimal answer. Can I divide 18 by 5? Nope. In that case, I've got all my factor pairs, or my pairs of factor shoes, on my spider, and notice that they're already in order from smallest to biggest. Starting from the left-hand side, I've got the factors 1, 2, 3, 6, 9, 18. And I know I haven't missed any because I worked from the smallest up as well as the biggest down till I meet in the middle. Let's try a few examples to make sure you can do that. Feel free to hit pause here and try for yourself, but I'm going to keep going right through this. So for example 2, the factors of 12 I know that all values can divide by 1, so I'll start with that. 12 divided by 1 is 12. The next number I might try is the next smallest number, because I'm going in order here. 12 divided by 2, yes, it does divide by 2, and that's 6. So there are no factors of 12 anywhere between 6 and 12. That's my next highest factor. What's my next lowest factor? After 2 comes 3. Can I divide 12 by 3? Yes, I can. And 12 divided by 3 is 4. Well, that worked out nice because I have no other numbers to try. My next highest factor was 4, while my next lowest factor was 3, and there's no values between that. So those are my factors. 1, 2, 3, 4, 6, and 12. How about for 54? Go ahead and try that for yourself if you like. So write 54 at the center of your spider and start with the smallest factors of 54. Hit pause if you like. I'm just going to keep going through. The smallest factor is always 1. And whenever you divide by 1, the value doesn't change, so the highest factor is always the number itself. So the next smallest factor would be 2, because 54, can 54 divide by 2? Yep, 54 divided by 2, that is 27. Next, I'll try 3. Can 54 divide by 3? Yes, it can. 54 divided by 3 is 18. What about 4? Can 54 divide by 4? No, it can't. 40 can divide by 4. 48 could divide by 4. The closest multiple of 4 that I can think of is 52. That's 4 times 13. But I can't divide 54 by 4. So what about 5? No, the closest multiple of 5 I can think of is 55, which would be 5 times 11. So what about 6? Yes, I can divide 54 by 6. 54 divided by 6 is 9. The only numbers I have left to try are 7. Can I divide by 7? No, the closest multiple of 7 I can think of is 56, which is 7 and 8. And I can't divide by 8 either. So that's it. My factors of 54 are 1, 2, 3, 6, 9, 18, and 27, and 54, of course. Finally, for 20, go ahead and set up your factor spider. Start with the smallest factor, that's 1. It gives you the biggest factor. 20 divided by 1 is 20, so we've got a pair. Next, we'll try the next smallest number, 20 divided by 2. Yeah, that divides by 2, and it's 10. Does 20 divide by 3? No, the closest multiple of 3 I can think of is 21, which would be 7. So skip 3. Can we divide by 4? Yes, 20 divided by 4 is 5. So we've got all of our factors. There's nothing left to try between 4 and 5. So let's put them in order here. 1, 2, 4, 5, 10, and of course don't forget 20. We'll get back to finding factors in a minute, but let's now look at prime numbers. As we've said before, prime numbers are the numbers that have exactly 2 factors. That's 1 and the number itself. Then you could go looking for other factors, but you won't find any. So prime numbers, rather than looking like spiders with legs with matching shoes, they actually look a bit more like aliens with antennae like this. Some helpful tricks to check for factors when you think a number's prime, but you're not sure if it has any other factors, are as follows. The first trick is that if a number can't divide by some value, then it can't divide by any multiple of that value either. For example, if a number can't divide by 2, so an odd number, it can't divide by 2, then it also can't divide by any other even number. It can't divide by 4, 6, 8, 10, or so on. We'll demonstrate that in a minute. Similarly, if a number can't divide by 3, that means it also couldn't divide by 6, 9, and 12. 3's times tables. Also, if it can't divide by 5, that means it couldn't divide by 10, 15, or 20 either. I hope you understand that. I'll demonstrate in a minute. The second trick for checking for factors is that if you start with the smallest factors and finding the biggest factor pairs, you can stop looking for factors when you've reached a pair which is smaller than the number you've just divided by. Now, I'm going to need to demonstrate that as well. But you're going to want to write these tricks down because once you understand them, you'll find them very helpful. So let's get into an example. How about 37? First of all, let's think about all of the possible factors of the number 37. And there's a lot of them. Any number from 1 to 37. But by using these tricks, we're going to eliminate a lot of these possibilities quite quickly. First of all, starting with the lowest possible factor, 37 does divide by 1. And when we divide 37 by 1, we get the highest factor, which is 37. So I've got a pair of factors, like a pair of antennae, like my factor alien up here. But is 37 a prime factor alien? Or is it a spider? Are there more legs that I need to put shoes on? Let's try. Can we divide 37 by 2? No, because 37 is definitely an odd number. It has an odd number in the units, so it can't divide by 2. If it can't divide by 2, it can't divide by any of the other even numbers. So as you can see, I've blacked all of those out. They're not possible factors for 37. You could try all of them if you like, but you'd be wasting your time. If you want to hit pause and give it a go, feel free, but I'm going to keep going. Next, I'm going to try 3 because it's the next smallest possible factor. Does 37 divide by 3? No. 36 divides by 3, that would be 12, but 37 does not divide by 3. So I'll black out the 3, and I'll black out all of the other multiples of 3 as well. You see how I'm getting rid of all of the possible factors quite quickly here? Next, I'm going to try 5. It's the next possible factor, but 37 cannot divide by 5. The closest number I can think of that can divide by 5 is 35, and 35 divided by 5 is 7. So the factor pair for 35 is still higher, so I'm going to keep going. But 37 itself does not divide by 5, so I'll black out the 5, and I'll black out all the multiples of 5. So the next possible factor I'm going to try is 7. And as I've just said, 35 divides by 7, but we're not talking about 35 here. We're talking about 37. 37 does not divide by 7. But if I tried dividing 35 by 7, I'd get an answer of 5. And that answer is smaller than 7. That means that I don't need to try any of the other factors because if 11, 13, 17, or 19, or so on, were factors of 37, when I divide by any of these values, I would get an answer that is smaller, which would mean that they would have to have already been found. And I've tried everything up until now, so it's a prime number. It's got no other factors, so it's got no other legs. Rather than a factor spider, we've drawn a prime factor alien. I hope you remember this exercise from our introductory lesson to factors and prime numbers. If you didn't see that video, I'm linking it down in the description box below. But we identified our prime numbers from 1 to 100, and this is what we had. You should recognize most of these, at least the smaller ones too. If you can't remember your prime numbers, you're going to have to check for them. Remember by looking for any factors that they might possibly have other than 1 for themselves. Now we're going to use our knowledge of prime numbers to find the prime factors for any value. To find the prime factors of 18, we'll start by setting up a prime factor tree. Not a factor spider. We're not interested in finding all of the factors, only the prime factors. Now, prime factors are interesting because they're the factors that cannot be broken down into smaller parts. Their only factors are 1 in themselves. Starting with the smallest prime number we can divide by. Remember our prime numbers 2, 3, 5, 7, 11, 13. You don't need to remember them all because we'll always start with the smallest. 2. Does 18 divide by 2? Yes, it does. So we'll write the prime factor on the left side branch, and we'll write its factor pair on the right-hand branch. So 18 divided by 2 is 9. I circled the 2 because that's a prime number, but 9 is not. In step 3, we look at our factor pair that we just ended up with, which was 9. And if it's not a prime number, we go back and repeat steps 1 and 2. So step 1, divide by the smallest possible prime number. So again, starting with the smallest prime number, which is 2, but 9 does not divide by 2. So we move on to the next smallest prime number, and that's 3. 9 does divide by 3, and 9 divided by 3 is 3. Now our factor pair is a prime number. 3 can't be divided by anything other than 1 in itself. So that means there are no more prime factors of 18. If we've done this correctly, we should be able to write our original number 18 as a product of its prime factors. Now, product means multiplication. So that means I could write 18 is the same thing as 2 times 3 times 3. Not the 9, because 9 is not prime, and I've already taken the 9 into account when I split it down into 3 times 3. 3 times 3 is 9, times that by 2 gives us 18. Another way of writing that is saying that 18 is equal to 2 times 3 with a power of 2, because I'm multiplying 2 of these 3's together. 2 times 3 squared, that is. Let's find the prime factors of 57. Again, start with our prime factor tree. So I'll start with 57, and I'm going to branch that out, starting by dividing by the smallest prime number that I can. Now the smallest prime number is 2, but 57 is an odd number. It won't be divisible by 2. So I'll try by 3. Does 57 divide by 3? Yes, it does. 57 divided by 3 is 19. Now 19 is quite a big number, but it's actually prime. We could check if it's prime by trying to divide it by the smallest possible prime number. It doesn't divide by 2 because it's odd. It doesn't divide by 3. The next prime number is 5. It doesn't divide by 5. The next prime number is 7. It doesn't divide by 7. Then after 7 comes 11. It doesn't divide by 11. Doesn't divide by 13. Doesn't divide by 17, which takes us to our next prime number being 19. So 19 is prime. So in this case, 57 is semi-prime. It's only got 1 itself and these prime factors as its factors. So 57 has factors 3 and 19 and can be written as a product of prime factors being 3 times 19. Let's try another one. 126. A bit bigger this time, but we'll always start with the smallest possible prime factor. Does 126 divide by 2? Yes, it does. It's an even number. 126 divided by 2 is 63. 63 now is not a prime number, so we have to think, what prime number can we divide 63 by? Starting with the smallest prime number, but 63 does not divide by 2. It's an odd number. So let's try the next smallest prime number. 63 divided by 3? Yes, that gives us 21. 21 is not a prime number though, so we have to keep going. It doesn't divide by 2. Does it divide by 3? Yes, it does. 21 divided by 3 is 7. And 7 is a prime number. You can check by seeing if it divides by any of the prime numbers smaller than it. It doesn't divide by 2. It doesn't divide by 3. It doesn't divide by 5. So 7 is prime. So 126 has got the prime factors 2, 3, and 7. And just to check if we've done that correctly, 126 should be the product of its prime factors. 126 is equal to 2 times 3 times another 3 times 7. That's the prime factors we get from the tree. 2, 3, 3, 7. Check that on your calculator if you're not sure, but it should give you 126. Now let's go on to some practice. Go ahead and list the factors for the numbers in question 1. That's going to require factor spiders, so you can find all of the factors. For question 2, we're just asked to write these numbers as a product of their prime factors. So we don't want to know what all of the factors are. We want to be able to split these numbers down into just the prime factors. So for question 1, we're using spiders. For question 2, we're using trees. And once you've drawn your factor trees in question 2, check that you've done it correctly by multiplying together your prime factors and see if that gives you the value we started with. Now go ahead and hit pause and copy those questions. Show your working, show your spiders and your trees, list your factors out, or write out the multiplication of those prime factors, and hit play when you're ready to take it up. I hope you had a chance to hit pause, because here come your answers. For question 1, and for question 2 with our trees, 120 should be the same as 2 to the power of 3 times 5. 83, splitting that down to its prime factors, it is a prime number. It doesn't divide by 2, doesn't divide by 3, 5, 7, 11, and I kept going through my prime numbers. It's got no factors other than 1 in itself. Question G, 64, splitting that down into its prime factors, it divides by 2, divides by 2 again, divides by 2 again. How many times do we divide by 2? Count all of your prime factors. That's how many 2's you've got there. 64 is the same thing as 2 times itself 6 times, or 2 to the power of 6. Question H, 77, doesn't divide by 2, 3, or 5, but it does divide by 7. And 7 is prime, and so is 11. So 77 is equal to 7 times 11 as a product of its prime factors. So how did that go for you? Please let me know down in the comments section if you're still a bit unclear about any of this. But if you are just curious about why this is helpful or why we would ever need to use the prime factor tree, let me show you an example of what you might see on a non-calculator paper. So given that 64 is equal to 2 to the power of 6, which you would need to be able to work out for yourself, as we just have, and 120 is the same thing as 2 to the power of 3 times 5, I wonder who could simplify this fraction without a calculator. I'd be very interested to see who can solve that for me. Until next time, keep practicing, and I'll see you soon with our next lesson where we apply our factor spiders and factor trees to find common factors and highest common factors. Till then, take care and I'll see you soon.